ZXL Corpio, calculus, volumes of revolution, rotation about the y-axis. So this time we're going to take the curve y equals f of x and rotate it about the y-axis to create a volume of revolution. So we're looking for the region between the y equals f of x, the y-axis, and the lines y equals c and y equals d. That is fully rotated 360 degrees about the y-axis to give the solid shown. So again we consider a thin disk. So if we annotate the diagram and think of a point on our curve which is x, y, the radius of this disk is x, and if we look at the thickness of this thin disk, it would be delta y. So if we look at one disk first, the disk volume is pi, and the radius is x, so it's pi x squared, and the thickness is delta y. So that's one disk, so that is delta v. That is just a small volume, a small part change in the volume. So if we look at the total of all the disks, the total of the disks would be the sum of these disks starting at y equals c and finishing at y equals d. So those disks need to, at the moment, they are an approximation for the required volume. So the exact volume, which is what we're looking for, will be the limit as delta y gets smaller, so the disks are getting thinner and thinner, but you're getting more of them, of the summation pi x squared delta y from y equals c to y equals d. And as delta y approaches 0, the volume, the exact volume, becomes the integral of pi x squared. It becomes a dy from y equals c to y equals d. And that is a rotation about the y-axis. So you need to make sure you use the right formula for the correct rotation. So just to put a little bit of detail on there, so the volume of one disk is delta v, and the volume we're looking for after doing the summation is pi x squared dy from y equals c to y equals d. Notice that in this case the integration is carried out with respect to y rather than x, and the limits of integration are the y coordinates rather than the x coordinates, so you need to be extra careful setting up your solution. So here we have an example. The region bounded by the curve y equals 2x to the half. The y-axis from y equals 2 to y equals 4 is rotated about the y-axis. Find the volume of revolution. So just to give you a crude illustration, so that point, when it's rotated about the y-axis, we'll do that. This point, when rotated about the y-axis, we'll do something a little bit like that. And the volume would look like this. That's the volume we need to find. So we've got to be extra careful with this one. We know that y equals 2x to the half, but we need to know what x is. So y over 2 is x to the half, and therefore that implies, if we square both sides, x will be y squared over 4. So when we come to do our volume, the volume would be v, would be the integral of pi, and it's x that we're squaring this time, so that would be y squared over 4 squared. Don't forget it's dy, y is the variable, and we're going from y equals 2 to y equals 4. So the volume is, I'm going to take the pi by 16 out as a common factor, the integral from y equals 2 to y equals 4 of y to the power 4 dy, which is pi over 16. So doing the integration with respect to y is a fifth y to the 5 from 2 to 4. So I'm going to take the pi over 80 out as a common factor. So putting the top limit in gives me 4 to the power 5 minus the bottom limit going in goes 2 to the power 5, which gives me a volume of 14 pi over 5. That's the exact volume generated. So here we have a clearer illustration of what's happening, and the really important part of this process is to make sure you've got a correct version of x squared ready to sub into your formula. V is the integral of pi x squared dy. So that's the really important step. And don't forget your limits are y going from 2, y going to 4. So here the region bounded by the curve y equals x squared minus 3, and the y-axis between y equals 4 and 5 is rotated fully about the y-axis, which is the correct calculation to find the volume of revolution. So first thing, we need to make sure we've got the right formula. So it's a rotation about the y-axis, so volume is the integral of pi x squared dy from y equals the starting value, which is 4, to y equals 5. So we know, if we go back to the equation, we know that y equals x squared minus 3, so it's the x squared that we need for our formula. So x squared must be y plus 3. So we can get the volume by integrating pi, and instead of using x squared we have to use y plus 3, and we're going from y equals 4 to y equals 5. So we can see that the correct volume is this second one. If we look at the mistakes that have been made in this first one, the mistake, it looks as though they've put in, instead of x squared, they've used y squared. So I've got the wrong formula. In this third one, it looks as though it's okay initially, but on closer inspection you can see they've missed out the pi from the formula. And the last one again looks okay, but on closer inspection you can see they've got the wrong variable. It should have been dy. So the correct one was the second one. And that brings us to the end of volumes of revolution.